This video is intended towards individuals that aspire to be software architects. We'll begin our story with apophenia, which is the tendency of individuals to see meaningful pattern between unrelated things or objects. And the classical example, which is often quoted, is showcased here. On the left, you see the scan or picture of neurons within the brain, and on the right is a structure which exists between a galaxy or within a galaxy. And while the picture on the left is at a micro level, while the one on the right is at a macro level, there is a remarkable similarity between the two. And such patterns also exist in structures or architecture. Now, a classical example of design pattern is about tunnels. Humans have been digging or constructing tunnels over centuries, but the basic form have remained the same. And it's a three-step process. First, you do the excavation. Second, you construct the tunnel structure. And third, you fill or cover it up. And this pattern is called cut and cover. Now, this book, which was published in 1970s, talks about design pattern as a language. And they describe that design pattern is a reusable form of a solution to a design problem, which can be seen over and over again. Now, with this understanding of design pattern, we'll see how software design patterns evolve. The first example of design pattern in software engineering is made possible by the contribution of these four gentlemen. That's why they're called Gang of Four. And what this showcase was a group of design patterns which were divided into three categories: creational, structural, or behavioral. Now, since then, more and more design patterns are identified, and design pattern in software engineering is a standard way or a response to a problem which can be seen again and again, irrespective of the language. This book, however, was not without critique, and a lot of people argued that these design patterns are heavily focused by UML, and also because of the advancement which is being made in high level languages, the need for design pattern is not as obvious as it was before. Nonetheless, if you aspire to be a software architect, it's a good idea to understand design patterns in general. So now I'll showcase you two examples of software design patterns where you can see that understanding of these design patterns can help you build software architecture or solution much gracefully. Now think of a software solution for a ride-sharing company, the likes of Uber or Curry. It's a black box for us right now, and the scenario is as such. There are people who are opting out for a particular taxi or cab service. Now, all four of these are going to compete for one particular resource, and that resource in our scenario being the driver itself or one of the taxis. So now we have a scenario which I want you to focus on. The requests arrive at a variable rate, which means that the individual who are opting for the taxi service cannot be predicted ahead of time. However, the resource at our disposal, which is the taxi, we could have a better determination of when it is going to be made available. Thus, the requests are processed at a consistent rate. Now, this is a rather simpler example, and in a real world scenario, even the availability of taxis could be slightly challenging. Now, take a good look at this system, and I want you to experience the same scenario but for a different sort of a solution. This time around, we have a system or a solution for a generative AI platform, which allows user to create generative AI video just by inputting a text. For example, a user comes up and says, give me a picture or a video for Stairway to Heaven or an asteroid crashing into Earth. So the request once again arrive at a variable rate, but the requests are processed at a more consistent rate. So you see, once you understand one class of problem and you understand the solution, that solution can be reused into multiple different systems. So now once we understand the problem, and the problem being that the requests are arriving at a different rate or a variable rate, but the responses are supposed to be made in a more consistent rate, what should be our response? Now, as you might have guessed, the standard response to such a problem is to introduce a queue. As users make up the request, they become part of the queue, and the introduction of queue minimizes the impact of peak in demand. It also ensures that there is a responsiveness for both the task as well as the service which you are extending to your customers. But this is a very simple scenario, so let's build on top of it. So let's say you are a customer who has made the request at the very last, in this case, Emily. But Emily opts out for a service where she is paying extra, which means that she is expecting better quality of service. And now we have a problem because in our queue, Emily was the last, as it can be seen here. And so we need a mechanism for Emily to be pushed on the front of the queue. And once again, we come across a class of problem which can be seen over and over again. And from an architectural or design patterns perspective, there should be a formal response to it. And the response is priority queues, which offer different service level guarantees to customer based upon their credentials. So in such an implementation based upon the economy, we will introduce two queues. One for the standard individuals, and those which are paying extra would be catered through introduction of priority queues. So this way, all the customer who are paying in a particular tier would become part of a standard queue, and the one who is paying extra would become part of the priority queue, and thus be offered better quality of service. Now, on the note of priority queues, there is a very interesting case study from Uber, which is not directly tied to design pattern, but I think it's good to talk about it. So somewhere back in April 23, Uber was accused to make use of the battery percentage and offer you a higher price if your battery percentage is lower. I do want to highlight that this was an acquisition which was made, and to the best of my knowledge, it was never proven. But nonetheless, this becomes a good study, and maybe knowing about it helps you in a better implementation of a system somewhere else. We'll move on to another scenario. So in this scenario, think of a physical location where a system is in place for a shipment company. The sender comes who has a bunch of packages which are to be sent. He puts it on a machine, makes some entries, and then the dispatcher validates those entries. And all those entries go into a mainframe system. But the problem we have is as follows. Since it's a shipment company, there are n number of such physical locations where such systems are in place. They may be exactly the same or somewhat different. And the problem at hand is that if you are to modernize such a system, would you start working at multiple locations at once, or do you pick up piece by piece? Now, the reason that I'm talking about this problem is because I want to highlight that design patterns are generally very intuitive. And as you might have guessed, the response is to incrementally replace the pieces of functionality or introduce new system one after another. However, in the design pattern language, there is a standard name for it, and this is called Strangler Fig Pattern. And let me showcase you a better example of it. So think of a legacy system which has three different modules: a user authentication in red, a dashboard in gray, and then emailing in blue. If you are to modernize it, Strangler Fig suggests that you begin with the piece which is the most crucial. So for example, we take up the user authentication and then we modernize it. Then we go on to pick up the next piece, which is the dashboard, we modernize it. And so this incremental process helps us achieve modernization. Now, with the basic understanding of few examples that we have seen, I highly recommend you to go through the proposed design patterns. I've highlighted the name as well as the use of each design pattern. For example, if you have to build resiliency in your system, whether you are building a mobile application or a web-based application, the circuit breaker architecture is a great pattern to evolve. From the perspective of performance, primarily in the mobile applications, the asynchronous request reply is a great pattern to learn. And similarly, from a security perspective, the gatekeeper pattern could be a good choice. So I hope that this basic video was helpful to get you started with the idea or notion behind design pattern.